the a values, instead of being positive, the a values are now negative. So my a values are negative, but my b value, remember, it's still a growth. So it's still increasing, but now it's flipped. So the positive growth was like this, but if my a value is negative, that means it's a vertical reflection. So it means you have to draw the reflection of the initial function. So that's what it's going to look like. And this is always decreasing, and then the last one is always increasing because of the reflection of this one here. So if you don't understand, if I went too fast, there are some notes and videos that you can take a look at. But yeah, those are your 4 different scenarios of increasing and decreasing. So you have to know which scenario you're looking at and tell me whether the function is always increasing or decreasing. All right, that's fine. We're gonna move on now. This is something you can do for sure. All right, lesson 5. Oh wow, a bunch of videos on lesson 5. So I recommend watching those videos for your own, benefit. Now we're doing transformations. Transformations. Let's do this one. So you graph the function g of x is equal to 3 to the power of 2x minus 4 plus 1. Now I chose this one specifically because this one has an extra trick. I don't know if you guys remember from the transformation video that we did previously. Do you see any brackets here? The answer is no. Why? Well, there should be brackets. The fact that there aren't brackets means that you need to rewrite it in a form that has brackets, because this function has both a k value and a d value. So you have to figure out what my k and d values are. So if you initially look at this, it looks like my k value is 2, my d value is positive 4 because it's the opposite, and my c value is 1. And there is no a value, or a value is technically 1 because it's the value in front. But sure, those are my values. But what if I told you that these are wrong? K, D, C, and A, something's wrong here. And I'm not lying, because what you need to do is you need to rewrite this in form of this. You have to factor out the common 2 from both the x term and the constant term. And now you have 2 brackets x minus 2. Now, inside those brackets is my d value. So my d value is actually positive 2. My k value is still 2. My c value is still 1. That didn't change. My a value is still 1 because it's the 1 in front. So just be very careful for the k value and the c value and whatnot. All right, what's the base of the function? So the base function is just y equals my base value, b, 3, power of x. That's it. So if anyone asks you what's the base function or the parent function when it comes to exponential equation, it's always just your base number, your b value, to the power of x. That's it. It's simple. It's meant to be simple. Now we describe the transformations. How do we describe transformations? We went over this many times, but I will go over this one more time again. So since there is no a value, or my a value is 1, that's a vertical stretch and reflection. But since a is 1, there is no vertical stretch or reflection. So let's move on to my k value. My k value is 2. So that is horizontal. Now, if my k value is 2, is that a horizontal stretch or is that a horizontal compression? And if you remember from your note, that is horizontal compression by a factor of 1 over 2. That's my k value. My d value is 2, so that's obviously shift right by 2 units. My c value is 1, so that's obviously shift up by 1 unit. And yeah, we're done. So we got your d, k, c, and your k value. There's no reflections because nothing's negative. A value is not negative, k value is not negative, and there's no vertical stretch or compression because a value is 1. So I've described my transformations. Let's move on now. Gotta make a table of values. here, table of values, a lot of students made a mistake here on the test with their mapping notation, even though I went over mapping notation many times. And I'm going to go over it again. So how do I make my table of values? Well, first, your base function. Y equals 3 to the power of x. You just got to make your table of values for your base function. And just pick some easy points like -2, -1, 0, 1, 2. Very simple basic points. And plug them into the equation. Well, here, it's easy for me to plug in a 2. What's 3 squared? That's obviously 9. What's 1? What's 3 to the power of 1? 3. What's 3 to the power of 0? 1. Clearly, you can see the pattern. It's going, if you're going in reverse order, it's going down by 3. But it's technically growing. So if you're going in reverse order, divide by 3, divide by 3, divide by 3, divide by 3. There you go. Very simple to get the base function. It's not hard. Now for the transform function, it takes on the form of x over k plus d, comma ay plus c. If you remember correctly, my k value was 2, my d value was also 2, my c value was 1, and my a value was also 1. So this becomes x over 2 plus 2 and 1y, which doesn't, remember, when you multiply anything by 1, it doesn't do anything. It doesn't change anything. So y plus 1. Now I plug in -2 into my mapping notation. What's -2 divided by 2? That's -1. -1 plus 2. -1 plus 2 is just +1. -1, plug it into here. -1 divided by 2, that's -0.5. -0.5 plus 2 is 1.5, or 3 over 2. 0, when x is 0, that's just 2. When x is 1, that's just 2.5. When x is 2, that's just 3. Alright, I got my x values. What about my y values? Well, that's 1 over 9. And you are allowed to use decimals. I just use fractions because when it's a nice fraction. So 1 divided by 9 plus 1. I'll just do it in decimals because I feel like students, it's easier for them to see decimals. Alright, remember, so we're just adding 1 to all the y values because that's all our mapping notation tells us to do. Once I have my mapping notation, I can graph the transformed function. Oh man, I shouldn't have. Placement was whatever, it's fine. Should be able to graph it still. Okay, so here we have x, here we have y. When x is 1, y is 1.1. So we're going to assume we're going up by 1. So 1, 2, 3, 4, 5. Yeah, so each block is 1, 1, 2, 3, 4, 5, 5. Okay, now that I got my scale, this is important to show your scale. If you don't, then you're not really getting full marks for graphing. Alright, 1 and 1.1. So 1 is here and 1.1 is, well, 1's there. 1.1 is probably like that. Alright, 1.5. So 1.5, that's between 1 and 2. And that's 1.33. So it's actually bigger than that one. It's probably like there. 2 and 2. So 2 is here and 2 is here. That's an easy one. 2.5 and 4. So 2.5 and 4. So 2, 3, 2.5. 1, 2, 3, 4. That's there. 3 and 10. So that's 1, 2, 3, and 10. That's up there. Clearly you can see it jumps up a bit. Oh, you know what? Let me just make a thinner line. You guys can see the points. And sometimes it's hard from the graph alone to tell you where the asymptote is. So remember, always take a look at your C value. That is your asymptote. Y is equal to 1 is my horizontal asymptote. So if I'm looking at my C value, the horizontal asymptote is at when y equals 1. So this is how you would draw it. If you want to extend it, you can extend it a bit. But yeah, be careful not to do what I did, and that's